Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about our research entitled Shelf-Life Estimation of Mocaf Dry Noodle Using Critical Moisture Content Approach in Various Type of Packaging, presented by me, Ardiba Sefrienda. The introduction of our research is about noodles as one of popular food in Indonesia, but the raw material is still imported. So we developed the noodles from Mocaf as local food diversification. But we still lack information of Mocaf noodles shelf life. So we estimated the shelf life using accelerated shelf life tests with critical moisture content approach. Before we predicted the shelf life, we determined the chemical composition first, and this is the methods for our research, the moisture content and S content using thermogravimetry, fat content using chocolate extraction, and protein content using Kildare. And the last, the shelf life using accelerated shelf life test by using moisture sorption isotherm or critical control approach. And this is the predicted shelf life stage in our research. The Mocaf dry noodles. Then we determine the initial moisture contents, the solid weight, packaging permeability, and the surface area. And we determine the critical moisture content using hedonic test. And to knowing the slope of MSI curve and equilibrium moisture content, we're storing the Mocaf dry noodle without packaging in high relative humidity container. And all the value, then we put it in this equation to predict the shelf life of Mocaf dry noodle. And here the results and also discussion. The chemical characteristic of Mocaf dry noodles we can see in this table. We can see that the protein content of Mocaf dry noodle is still low because the Mocaf is not the source of protein, not like the wet noodles. And we go to the shelf-life predicted test. First, we must knowing the initial moisture content and the solid weight. Using thermographic method, we conclude that the initial moisture content is about 13%, and the weight sample then corrected with initial moisture content to determine the solid weight, and we get that the solid weight is about 115 grams. Then we determine the critical moisture content by storing Mocaf dry noodles without packaging and then periodically tested by 13 untrained panelists by breaking the noodle roots. And the score is 1 for hard to match and 7 for very easy to break. And when panelists scoring 3, it means that it's slightly difficult to break. It means that it's refused by panelists. And plotted score to equation, and we get that the critical moisture content is about 15.8%. And the equilibrium moisture content obtained by conditioning the Mocaf dry noodles in 7 types of saturated salt solution with different relative humidity. And this curve and this equation, then we plot it to GAB curve to knowing the water activity at initial moisture content and in the critical moisture content. So we can get that in initial moisture content, the water activity is about 0.49%, and at critical moisture content, the water activity is about 0.61%, 61. And then we get this equation, so we can conclude that equilibrium moisture content is about 18.8%. For packaging permeability, we're using water vapor transmission rate. We use two types of material, PP and metallized material. We can see that PP material has the higher water vapor transmission rate than metallized material. And for the packaging surface area, we calculate the total area of the two phases of the primary packaging, and we can get that the surface area is about 0.07 meter square. So we get all of the value to this equation, and we conclude the shelf life prediction of Mocaf dry noodle using PP material is about 2 years, and using metallized material is about 6 years. Okay, that's all about my presentation. Thank you for your attention.